You do not explode, you do not freeze solid in an instant, you do not burst like a balloon. Space kills you far more quietly than the movies promised. Almost everything you've ever seen about this is wrong. What actually happens is stranger, slower, and over faster than you would ever guess. So let's do it properly. The airlock opens. There is no suit. And we're going to count the seconds honestly. The rules. A sudden total vacuum. No suit, no warning, a healthy body. And nothing but the real physics of what emptiness does to a person. You versus the emptiest place there is. Let's run the experiment. First, the one thing that could kill you instantly is a choice you're desperate to make. Every instinct screams, hold your breath. Do not. In a vacuum, the air trapped in your lungs would try to expand with nowhere to go. Holding it could tear your lungs apart from the inside. The one survivable move is the terrifying one. You breathe out, empty your chest, and let the emptiness take the air. Verdict, exhale, or the vacuum does it for you. Now the clock starts. The first 15 seconds. With the pressure gone, the water in your body starts turning to vapor. Your saliva bubbles on your tongue. Your skin puffs up, your soft tissues swell, but your skin is tough enough to hold you together. This is called ebullism. It's deeply unpleasant. It is not an explosion. You would puff up like a balloon. You would not burst like one. Dissolved gas comes fizzing out of your blood, the same way it does when a scuba diver rises too fast. Divers call it the bends. Out here, there is no slow way up. Meanwhile, your blood, stripped of pressure, stops delivering oxygen to your brain. You get roughly 15 seconds of useful consciousness. That is your entire window to be saved, and it happens in complete silence. Sound needs air to travel through, so there is nothing to hear, not the airlock, not your own shout. The pressure difference tears at your eardrums on the way out. You may well be deafened in the first second. Then, nothing but your own heartbeat. Verdict, 15 seconds of useful you. And what about freezing solid? This is the strangest part of all. Space is cold, yes, but it's also empty. An empty space can't pull the heat off your skin quickly. There is no air to carry your warmth away, so you would not flash freeze. Your body sheds warmth slowly, only by radiation. In direct sunlight, you'd have the opposite problem. With no air and no shade, you would start to overheat and sunburn. There's no atmosphere filtering that sunlight either. The side of you facing the sun takes the full, raw ultraviolet, the kind our air normally strips out before it reaches the ground. You would take a serious burn within seconds of exposure. Though in fairness, sunburn is not the headline problem you're dealing with at that moment. Verdict. Space does not freeze you fast. It suffocates you first. So if no one pulls you back in, how does it actually end? After you black out, your body keeps swelling and your oxygen keeps draining. Within about a minute to 90 seconds, the lack of oxygen becomes fatal. The cause of death is not fire or ice or bursting. It is suffocation. Space kills you the same way a sealed room with no air would. Just faster, and with far worse special effects. Animal studies from the early space program mapped that line precisely. Bring the subject back inside within about 90 seconds and it recovers. Past that, the damage doesn't reverse. Which produces a genuinely eerie fact. For that first minute and a half, you are not really dying of anything permanent. You are simply switched off, floating, entirely repairable, and drifting further from the only door. Verdict. In the end, it is simply suffocation. And we know all of this because it has actually happened to real people. In 1965, a NASA technician named Jim LeBlanc was inside a vacuum chamber when his suit lost pressure. The last thing he remembered was the saliva starting to boil on his tongue. He passed out in about 14 seconds. His team got the chamber repressurized within half a minute. He recovered completely, with no lasting harm. That 15-second window is real, and so is the rescue. There's an earlier case too. In 1960, Joe Kittinger rode a balloon to the edge of space and jumped. On the way up, his right glove failed. His hand swelled to roughly twice its normal size in the near vacuum. He decided not to mention it to ground control, in case they scrubbed the mission, and jumped anyway. His hand returned to normal within hours. It's why every airlock, every drill, every space station is built around those few seconds. Not minutes, seconds. That is the entire margin a human body gives you out there. But there is a darker case. In 1971, 3 cosmonauts aboard Soyuz 11 died when a valve let their cabin's air leak out on the way home. They remain the only humans ever to die in space itself. Verdict. Real. Survivable. And only for about 15 seconds. So, how long do you have, really? The honest scoreboard. Exhale and you buy your life. 15 seconds and you can still be pulled back. 90 seconds and it's over. No exploding, no freezing, just a fast, quiet suffocation. The universe is almost entirely vacuum. Trillions of miles of it, in every direction. and you can survive about 15 seconds of the stuff that most of the universe is actually made of. Everything keeping you alive is that one thin shell of air. Step outside it for 15 seconds, and the emptiness reminds you exactly how borrowed all of this really is.